Okay, spheres. Just kind of the three-dimensional version of a circle. So you may remember on a circle, the equation was your middle point, the center of the circle was given by hk. And the equation of a circle was x minus h quantity squared plus y minus k quantity squared equals whatever the radius was squared. Well, you can see from our formula that for a sphere that the center of the sphere is given by a, b, and c. The radius is r. And then the formula for a sphere is x minus the x value from the center squared plus y minus the y value from the center squared plus z minus the z value from the center squared is equal to the radius squared. So all in all, not that much different than the equation for a circle. All right, so two different types of questions you can be asked about these. We can either give you the center and radius and ask you what's the equation of the sphere, or give you the equation of a sphere and ask you what are the center and radius. So as you get going on these, they shouldn't be too bad. It's always x minus whatever the x value is squared plus y minus whatever the y value is, and then we square it, plus z minus whatever the z value is, and we square it. And on the other side, we put the radius squared. Now on this, the only simplifying down we should probably do on this is that y minus a negative 3, we can make that y plus 3 squared is a little bit better answer. And over on the right hand side, maybe instead of 3 squared, we leave 9 as our solution there. All right, these other ones, and I'm not going to do each and every one of them, we'll skip some of these, but let's do a couple of them. If our center was 4, 3, 5, and the radius was 3, well, it's x minus 4 squared y plus y minus 3 squared plus z minus 5 squared equals 3 squared, or we could just as easily put 9 over on the right hand side for our final answer. What happens if one of them is 0 though? Well, it's x minus 0 squared y minus 3 quantity squared plus z minus 6 quantity squared equals 2 squared. All right, that first term, maybe a little bit nicer answer would be x squared, but I'm not going to multiply out like the y minus 3 quantity squared or the z minus 6 quantity squared. I'm going to leave those intact as they are inside parentheses. Now, what about the opposite? Remember I said we had two different types. I could either give you the center and the radius and ask for the equation, or I could give you the equation of a sphere and ask for the center and radius. So in this case, the center, ABC, would be given by these values that are attached to the x, y, and z. Except for, remember, it's always x minus whatever a is going to be. So in this case, it's going to be a positive 3 for our a, a negative 4 for our b, and a positive 1 for our c. Over on the other side, remember it's always the radius squared. So I can take that, whatever's on the right-hand side, apply a square root to it, and this one works out and reduces down nicely. It's going to be a positive 4. Now I didn't bother with the positive and negative because the radius is a distance from the center to all the points that are on the sphere. Let's try one more. Okay, so on this one, we want to identify the center, ABC, and the radius. So remember, the A, B, and C are these values that are attached to the x, y, and z, but you kind of think about it as you have to switch the sign. I know it's not really what's going on because it's x minus whatever a is, but in our case, it's going to be a negative 2 for our a. Because there's nothing with the y, we can visualize this as y minus 0 quantity squared, so that's going to be a 0. And with the z, our c value is 4. Finally, square root of whatever's on the right-hand side. Square root of 25 works out to be 5. These don't always work out to be nice perfect squares on the right-hand side, but sometimes they do and you can reduce down. Hope this helps out as you're working on spheres.